Hello, welcome back to our series aligned with AP Statistics. Today it's all about quantitative data. We're going to look at what is discrete data, what is continuous data, and then we're going to look at plotting and then describing distributions. So we're going to look at dot plots, histograms, and stem and leaf plots today, and then we're going to describe what we see, the shape of our distribution and other aspects to what the distribution looks like. So let's begin. Let's talk about quantitative data. Quantitative data is numerical and can be measured or counted. There are two types of quantitative data, discrete and continuous. Discrete data is countable, often in whole numbers, like numbers of siblings you have. Continuous data, on the other hand, is measurable and can take any value within a range, like your height in inches. Let's classify some examples together. The number of pets you own? That's discrete. You can't have a partial pet. Time spent on social media per day? That's continuous, because we can break down the increments of time into smaller and smaller intervals. The number of text messages sent in a day, also discrete. You can't have half a text message. And heights of students in the class is continuous, because we can have smaller and smaller increments of height. Now let's learn how to represent data with different types of graphs, starting with dot plots. A dot plot is a simple way to display data where each value is shown as a dot above its position on a number line. Let's create one together. I've asked students to share their typical daily hours spent on social media. Okay, everyone, please come up and plot your typical number of hours you spend per day on social media. When creating a dot plot, we first draw a horizontal axis and label it hours on social media. This will be critical for all plots that you may create on the AP Statistics test. If a plot isn't labeled, the reader doesn't understand what graphed data they are observing. Then plot each data point as a dot above the corresponding value on the x-axis. Each dot represents one student's typical daily hours spent on social media. This student spends about 5 hours per day on social media. Since our tiny class only had 5 students, let's look at a dot plot of a class of 30 students from 2023. Notice the data is clustered around 4 hours per day. So this value is likely near the mean or median value for this data set. Next up, histograms. Histograms are great for visualizing the distribution of continuous data. Let's use the heights of students in inches. First, we divide the range of data into intervals, or bins. We'll use bins of size 5 inches. Next, we sort the data into these bins and count the number of student heights per bin. We then draw bars for each bin to show the frequency for that interval. Notice that the bars touch each other, unlike a bar graph for categorical data where the bars are separate. This is because height is a continuous variable. Lastly, let's create a stem and leaf plot. This type of plot helps retain the original data values while showing the distribution. Using the same height data, we'll split each value into a stem, the leading digit or digits, and a leaf, the last digit. For our graph, it is essential to include a title to give the viewer an understanding of the graph's content. Additionally, we need to provide a key for the stem and leaf plot to help the reader interpret the data accurately. For example, in our stem and leaf plot, 6, line 5 represents a data point where one of the students is 65 inches tall, or 5 feet 5 inches. Stem and leaf plots are particularly useful for small data sets. They offer a quick way to display the shape of the data distribution while preserving the original data values. Now that we've created these different graphs, let's talk about how to describe the distribution of a quantitative variable using the acronym SOCV: shape, outliers, center, variability, and context. In statistics, the term distribution refers to the way in which data points are spread out or arranged over a range of values. The distribution provides important information about the data set, such as where the majority of data points lie, the variability of the data, and any patterns or trends. It helps us understand the overall structure and characteristics of the data, such as its center, spread, and shape. Common types of distributions include roughly symmetric distributions, roughly uniform distributions, and skewed distributions. First, let's describe the shape of our height data distribution. Is it symmetrical, skewed to the left, or skewed to the right? For example, if our histogram of heights has a long tail on the left, it's left skewed. If it has a long tail on the right, it's right skewed. Looking at our height data, we see that it's roughly symmetric, with most data points clustered around the center and no long tails on either side. Next, we have outliers. Outliers are data points that fall far from the rest of the data. In our height data, an outlier might be a particularly short or tall individual compared to the rest of the group. While we won't dive deep into identifying them today, it's important to keep an eye out for unusual values. For now, you can just say, we have a suspected outlier if you see anything unusual. Now let's discuss the center of our height data. We could use the median or the mean depending on our data. Because the distribution of our height data is roughly symmetric, we will use the mean to describe center. If our data had been skewed, either right or left, we would have wanted to use the median instead. Variability refers to how spread out our data is. We often describe this using the range, although we have several other things that we use and we will talk about in future lessons. The range is the difference between the highest and the lowest values. It is a number. For our height data, if the shortest is 58 inches and the tallest is 78 inches, then the range is 78 minus 58, or 20 inches. So our range is 20 inches. And finally, context. Always interpret the data within the context of the problem you're investigating. So when you're talking about our height data, for example, you would say the average height is possibly around 65 inches. The range of heights is 20 inches. The context is crucial for understanding what data is telling us. It helps us make informed decisions and interpretations based on specific characteristics of the group we're studying. To summarize, today we learned how to classify quantitative data as discrete or continuous, and how to represent data using dot plots, histograms, and stem and leaf plots. We also discussed how to describe the distributions using the acronym SOCV for shape, outliers, center, and variability, while keeping context in mind. Remember, for roughly symmetric data like our height data, use the mean to describe the center. For data with significant skew or outliers, use the median. Thank you for joining me today. Don't forget to like, subscribe, and hit the bell icon for more AP Statistics aligned lessons. Stay curious, keep questioning, and remember, in statistics, every distribution tells its own story.